Hello everyone, my name is Tamas Zsiros and I'm here today with Henrik Saavedra Persson. And together we are going to talk to you about how do we enable end-to-end observability via open source in 5G telco CNFs. CNFs, if you haven't heard the term before, stands for Cloud Native Network Functions. So let's dive right into it. A bit about the journey. We are from Ericsson and we have a very extensive experience in building platforms of the monolithic type that sort of makes software and hardware work as efficiently together as possible. So we used in the past, and we're still using hardware acceleration, ASICs, custom OSs, kernel modules, you name it, we have it. And we build software and hardware together to make it work as efficiently as possible. However, there are quite many use cases where we have sort of moved away from that paradigm, moved away from the monolithic way of building things, where we sort of run hardware and software together. When we started using extensively software in the Cloud Native Computing Foundation, mostly in the landscape and mostly open source projects. And since we wanted to enable software development in a really cloud-native way inside of Ericsson, we have decided to build a framework out of some of the selected software that we take from open source projects and enable them within Ericsson to be used for telco purposes for very, very demanding use cases and applications. Of course, all the software that we take, we don't fork it, we don't modify it. If we have to modify it, we work together with the community and contribute back the changes and sort of implement an upstream first strategy. So we try to help the community as much as we can wherever there are things lacking. In other areas, we just take the software and make sure that they can fulfill the very strict requirements that telco applications are sometimes put against. So what are these use cases and what are these demanding use cases and applications? Well, let's see, for 5G, if we look at the 5G core part, there is the user plane for mobile broadband, for example. Mobile broadband is basically all of the network traffic that goes through mobile phones. So all the streaming, all the videos, your emails, your when you're working from home, potentially all that traffic goes through these network functions. So they, of course, have very, very, very strict requirements on availability, or on service continuity, but also on network throughput. Otherwise, they wouldn't be able to handle, the network traffic for a whole country or for a complete region when it comes to mobile broadband. But I can also mention another application where we create a management application that takes care of the management of the complete radio network, which typically consists of thousands, if not tens of thousands of network elements that all needs to be configured and managed from the software perspective, and of course monitored and health checked continuously within the network to keep that network operational. That again generates a lot of traffic going towards the management nodes. And those management nodes, of course, have to use the same software because the software lives in the core. I can mention radio equipment. Some of the radio logic now we are moving onto this platform, this framework that we have created out of CNCF software, private networks, edge applications, and so on. So it's very diverse set of different applications, all with mostly very demanding requirements on the platform and everything else around it. We have recently started using this platform for the 6G testbed, but that is of course just a testbed. So what we are concentrating most on is 5G. Then of course, everything that we do cloud natively on top of this framework needs to fit in existing environments, existing telco operators' way of working and paradigm, and so since these are very complex applications made out of many network elements, it's necessary to have some sort of management framework that keeps everything together. And this is where another Linux Foundation project the Open Network Application Platform projects comes into the picture, because that project implements a very capable management system that can sort of take care of the management of the cloud infrastructure, but also the applications and the transport. And that helps us to sort of fit our cloud native applications into a traditional telecom environment. What is the exact nature of the challenge? Well, let me show you. A typical telecom operator buys software from many vendors. And if you look at the complete stack, that is true for the different layers of the stack. So I try to show you in this picture the fundamental difference between a typical cloud native stack that a non-telco player might do versus what the telecom operators needs to deal with. So in a typical cloud native stack, and let me try to draw here, a developer picks some sort of cloud infrastructure, buys capacity from a cloud infrastructure, and then takes their own choice of Kubernetes distribution, chooses some of the platform services, maybe builds a platform out of those, creates the business logic, and then, if necessary, if the application's complexity really warrants it, creates management services. But everything is in one hand. Everything that is blue is coming from one player, and the cloud infra is coming from someone else. In the telecom world, the telecom operator wants to go out and buy software from many vendors. So they might pick cloud infrastructure from one vendor, or they might build their own cloud infrastructure. Quite typically, telecom operators have a private cloud, and either they build it themselves or ask a vendor for one. There is a Kubernetes distribution, and usually the Kubernetes distribution comes with certain services. And in a good case, all that and the business logic might be coming from one single vendor. So everything that is blue here is coming from, let's say, from Nokia or Ericsson or whoever else. Then very typical that the OSS, the management system, and the BSS, the business management system, is coming from another vendor. So it's an orange vendor and a light blue vendor. This is sort of the best case scenario. The worst case scenario could look like cloud infra from someone, Kubernetes with some services from someone else, then some business logic from another vendor or multiple vendors together with some services from the CNCF landscape, and then of course OSS and BSS and separately. All these needs to work together without extensive integration projects, because that would be just not cost efficient. And what we have been relying on so far for many years is of course standardization, and we participate in standardization and the operators participate in standardization. We together created things like 3GPP, where we agree on the interfaces. So even if the operator gets software from many different vendors, it should work well together when it's integrated together. Then of course standardization can be a slow thing and can be a cumbersome thing, and technology moves ahead at a very fast pace. So what we have been trying to do as much as possible is to try to refer to industry standards, and in many ways industry standards these days are dictated by open source projects. So I'll come back to this point, but here it is super important to have things like the CNCF Landscape, to have the Cloud Native Compute Foundation, and have ONAP that sort of creates a common denominator across the industry. So how does this stack look like? I mentioned the application development framework. Here you see the input for that is the CNCF Landscape, and these logos should be very familiar to you, so I will not go through these in detail. The idea is that all of these highly demanding applications can be built on top of this framework, not just network functions, which are standardized by 3GPP, but also any sort of application and telco application can be built on top of this framework. Then inside the framework, we are sort of grouping things into different groups. We have things that take care of life cycle management. We have, of course, databases, which are super important, since quite many of the telecom applications are very, very stateful, and then those states need to be stored somewhere in a cloud-friendly way. So what we do, we take on databases into the framework, and we ensure that we can lifecycle manage those databases using, for example, Kubernetes operators. Configuration management, performance management, and fault management, these are very traditional, typical telco things. I need to be able to configure my network, so I can set up the necessary interfaces and timers and behavior of the network. Performance management is basically monitoring, looking at all the KPIs and making sure my system is operating perfectly. And fault management is when things go wrong, I want exact indications about what went wrong, and I need to see these in priority order in my management system, so I or the ones who is managing the system can make the right actions. Henrik will talk a little bit about how do we enable these things inside our framework. But it's very important to mention that even though we have to extend here what is available in the landscape, it's important to have the interfaces going up from these CM, PM, and FM functions. Those are industry standard. So above this, we can have any Kubernetes, of course, because the software here in the CNCF landscape works mostly on any Kubernetes, and our intention is not to create a tie-in between the framework and the Kubernetes distributions. It should be freely selectable by the telecom operator, and of course, underneath, any hardware can live. On top of it is the management system. The Open Network Automation platform provides us the industry standard for the interfaces here for the CM, PM, and FM. But it provides us much more than just that. It provides us a technology source to build our management systems. And of course, we do many contributions back to ONAP to make sure that we progress in lockstep with the open source community. It gives us a reference architecture which makes sure that whatever management system we create will be compatible with any extensions others might be doing in this space. Interfaces and models are super important when it comes to the CM, the PM, and the FM, because this ensures that any applications that we create using the application development framework will work with a third-party OSS as long as that third-party OSS also follows the ONAP project. And of course, it's a standardized automation platform for making sure that all the lifecycle management tasks that we need to do with our cloud-native applications can be done efficiently. So this is how basically the CNCF itself and the landscape and the software itself gives us the modularity towards the cloud infrastructure, but also the ONAP projects provides us the modularity on the northbound interface for the management interfaces. Then I let Henrik to go a little bit into detail of what are the additional complexities and how do we make sure that we sort of fulfill all the requirements using the right level of abstraction.
So, as Tamas already mentioned, my name is Henrik Saavedra Persson, and I'll give you a little more details into the complexity and abstraction that we need to address within the telecom domain as such. So, the first one, if we look into what we really provide, like any other telecom vendors, is that we develop network functions, or an NF, which is also called, which is typically, so that's that software we really develop. But what really happens after that is that we hand that over to the telecom operators that operate these network functions. So there's a clear software handover here, not even talking about different organizations, but really completely different companies that develop and operate this. So that's, of course, creates a completely different challenge in the whole DevOps flow as such, that needs to be bridged in some way. If we look into one specific network function, then it can typically be up to 100 different microservice types that it really exists or creates a network function as such. And if you go to the next level, looking at more like a network, a telecom network as such, it contains several different network functions, and of course many instances of each network functions within that network as such. If we look at what already existed before, we went going cloud native and even 5G. There is an organization, 3GPP, that is standardizing the telecom domain. So there exists a lot of different standards already. And of course, those still needs to be fulfilled, and customers are expecting that they are still fulfilled going forward. The same organization, of course, also standardizing how to do the 5G as such. Then, as Tamas already mentioned, we have ONAP that creates expectation on how the different CNFs should be managed. And that comes in different areas. One area is configuration management, so by using netconf-yang, but also how different data is exposed towards the management system. So this, of course, this data is can be performance management data, fault management data, or logs or trace as such. And if you really look at then a network function with this up to maybe 100 different microservices types, it can easily become extremely complex and costly to configure and manage them on an individual microservices level. And of course, that puts also a lot of internal architecture focus and details on how you need to configure these kind of things. And then keep in mind that the one who actually operates didn't develop them, so they typically don't have that kind of maybe deep knowledge into the architecture as such. So what really the operator is looking for is a focus on how to manage, configure the different network functions that they bought or want to actually run as part of their network. So an aggregated view from the network function point of view really helps to abstract this and give a meaning to the operator that really needs to operate the network functions. Then, of course, looking into the cloud native landscape and CNCF, we see, of course, that there adds a lot of value in the kind of observability capabilities that is created within that ecosystem. But of course, we don't see that these existing 3GPP standards would just go away and this transformation would happen overnight. So we really see that existing standards and the cloud native de facto standards that are happening right now will have to will coexist for a long time. So this is really kind of the landscape that we need to be able to operate in and provide value both to our existing customers that still are maybe in the not fully going cloud native yet, so still more relying on existing standards, but also of course be able to provide all the kind of needed, and we see the value that cloud native can bring. And to give two examples in this, I will first dig into the performance management, where we say that we would use one same core, but allow it to be exposed in different ways. And this one core is really Prometheus that we use as the core infrastructure to provide performance management. So like in any cloud native application, Prometheus is continuously scraping metrics from the different microservices that belongs into that network function. And then, of course, depending on the different needs we have, we can expose these metrics in different ways. And how we do that is typically by developing different individual exposure services, as we call them. And these services typically are consuming provided APIs from Prometheus, and then providing an external data format that is needed for the different type of standards we need to align to. So, for example, in the ONAP case, there is a VS exposure service. Going back a little bit further, 3GPP has already defined a standard since a long time ago when it comes to performance management and the XML format that those files needs to have. So that's another service, and we can expose the data complying to that standards as well. But then, of course, at the same time, we want to be able to provide it more in a pure cloud native approach as well. So it's still possible to actually use Grafana or similar tools to consume the metrics directly from Prometheus. So this is a good example where we really try to bridge the existing standards, but also at the same time, we see how we can get the value from what really cloud native provides as such. And this also enables us to provide different scope of the metric consumption. where typically maybe ONAP and 3GPP has also the view of a bigger network, the telecom network view as such. Whereas Grafana also allows us to really drill down into individual microservices to really understand how they're performing, or if we can, if there's any kind of performance or errors that we need to address in some way. If we look into that, then the second area, configuration management, where we also then try to bridge these kind of different, more cloud native and the standard expectation from the telecom domain as such. So what we've done in this area is to really clear separation between the internal and external configuration model, whereas the internal model really focus on the microservices point of view, what that microservice is providing, and configuration makes sense from that point of view. Whereas you can see the external model is more driven from potentially different standards, Yang and these kind of things, and typically netconf Yang is what's expected from ONAP and other existing telecom management systems, I would say. And then at the same time, we have done a decentralized approach to allow this kind of internal configuration to be as simple as possible for the individual microservices, and really allow the microservices to own its own configuration. So as you can see in the picture, depending on the need, it might be as simple as some Helm parameters when you're deploying that service. That is the way to configure it, or a little bit more complex, maybe going for a config map or similar. But we also see that there are some cases where those maybe are not enough. So really, microservice brings in its own configuration database to be able to handle maybe a different type of configuration, and maybe also the amount of configuration it needs to handle as such. But what's really needed at the end from a telecom point of view is this kind of system aggregated configuration point, and that's really what the netconf Yang exposure can bring you. So that, and of course, when you need to configure one network function, that really brings different services together, and that's also then, of course, the API or the configuration model there is more centric around the network function resource model compared to the individual microservices resource model as such. And in many cases, this could also mean that to configure a network function, you have to, of course, configure magnitude of different microservices internally, which is really then handled by this exposure service here. And it could also, in some cases, mean that you have to push the same configuration to several of different microservices because they have the same need. But once again, to allow the microservices to individually own their configuration, this is handled by the netconf, so the exposure service. So it's really pushed down to the individual microservices. So to sum up, what we see is that there is a tremendous value in the whole CNCF ecosystem, even for telecom. And of course, that's really what we want to make sure that we can make use of, and then bridging these different standards, and then at the same time also bring the whole cloud native capabilities into our customers. And what we have done within Ericsson is to build this modular POS or framework, as we would like to call it, that can really bring value to 5G, and of course also to all other applications or network functions that we are also moving towards cloud native as such. But as you saw, I mean, the management complexity is extreme, but here we see that ONAP is really helping to drive simplicity and alignment as such. But we also see that open source helps to standardize, creating these de facto interfaces that enables this modularity. And as you can see in the examples, that allows us to support existing and new needs with this kind of independent, different exposure services. So with that, I'd like to thank everyone for listening, and that's all for us.